Okay, so today we're going to be working on some formulas with some word problems. All right, so these are the formulas that you need to know here. All right, the first one is the compound interest formula. All right, so these might look familiar from Algebra 1, right, because you did do this in Algebra 1. So the formula for compound interest, and we could also use this formula for exponential growth and decay. So also put that in here. Exponential growth and decay. Okay, this is the one that we're really going to be using a lot. All right, so the formula is A equals P times 1 plus R over N raised to the NT power. So P is your principal, or it's your initial investment. It's what you're starting off with. Okay, it's also called the principal. It's your initial investment. Okay, it doesn't always have to be money, okay, when we're talking about exponential growth. Okay, so it's just your initial, it's what you're starting off with. R is your rate. Now your rate is always expressed as a decimal. All right, so when it's given to you as a percent, you have to move the decimal 2 places to the left to express it as a decimal. N is the number of times it is compounded yearly. Okay, so if we're talking about money in a bank, compounded quarterly would be N is equal to 4. If it says compounded daily, that would be 365 because there's 365 days in a year. If it says compounded monthly, that means it would be N would be equal to 12 because there's 12 months in a year. When we're talking about exponential growth, though, or decay, not the interest, your N would be 1. All right, and T is time. All right, we also have this over here, this compound continuously. Okay, this is when something gets interest all the time. It just keeps gaining interest. It never stops. Okay, so that is the PERT problem. I call this PERT, okay, because it's PE to the RT power. All right, P is your investment, your principal. R is your rate, and like before, expressed as a decimal. T is your time. So when something says compounded continuously, then you would want to use the PERT problem. That's the only time you can use PERT, is compounded continuously. All right, now we also have this formula. This is the exponential growth and decay. So you'll see this formula. Usually the formula is given to you with the numbers already inside the formula. So what you need to know is what these are all representing, the y sub 0 and the k and the t. So y sub 0 is your initial amount. So if the problem is talking about the number of amoebas that are, let's say, in a petri dish, and it says the number of amoebas in a petri dish start off as 20, then 20 would be your y sub 0. K is your growth or decay constant. Growth or decay constant. And T is your time, whatever that time is, whether it's days or hours. All right, and we'll also be using this one here, this half-life. So if something's talking about half-life, this is the formula that you wanted to use. And again, y sub 0 is the initial amount. T is your time, depending on, what it is, whether it's hours or years. H is your half-life. If it says the half-life is 145 days, then H would be 145. All right, so you have to make sure that you know this formula inside out. This formula can be, instead of a plus, it could be minus, depending on if it's a decay, if it's something that's decreasing. So you know it as A equals P times 1 plus minus R over N raised to the NT power. Because it could be a plus, it's plus if something is increasing, growing. It's minus if something is decreasing, decaying. Make sure you know PERT. PERT is pretty easy though. And make sure you know the half-life formula. This one here, just make sure what you want to know is what these all represent. Y sub 0 and what your K is equal to. Because when you do have growth and decay, you could always use this formula here. Your N will just be equal to 1 all the time. All right, so let's look at the problem down here at the bottom. It says a total of $2,000 is invested at an annual interest rate of 4%. Determine the equation that would be used to find the amount invested after 2 years if compounded semi-annually. How much she will have in the account after 4 years. Okay, so this is an investment, so we're going to use the compound interest rate here. All right, so let's write the compound interest rate down. I'm going to move everything up though. Okay, so the compound interest is A equals P times, and since something is going to be growing, you're getting an interest, not decaying, it'll be a plus, it'll be 1 plus R over N raised to the NT power. All right, so on the side, let's just write down what we know. So P is your investment, is what you're starting off with. So P is equal to 2,000. R is your interest rate. So this is 4%. Now remember, we want to write it as a decimal. So the decimal is right here. Move it 2 places to the left. So that would be 0.04. N is the number of times it's compounded yearly. So this says it's compounded semi-annually. That means 2 times. And T is your time. All right, so first it says determine the equation that would be used to find the investment after T years. So right now T is just T. We want to come up with an equation that we could use all the time. All right, and then we're going to make T equal to 4. So let's just start with the first part. Okay, so the first part is just to come up with the equation for T years. All right, so I have A is equal to, P is 2,000 times 1 plus the rate, which is 0.04, over N, which is 2, raised to the 2T power. So you could leave it like this. This would be an acceptable answer. It doesn't say to have it in simplest form. But if we want to put it in simplest form, we would want to do the inside of the parentheses, because that's what PEMDAS says to do first. All right, so parentheses. So this is A equals 2,000 times. This you can plug into your calculator. 1 plus 0.04 divided by 2 is 1.02 raised to the 2t power. So this would be the equation for finding how much money she would have in her account semi-annually at an interest rate of 4% if she deposited $2,000 to start off with. All right, so next part is how much will she have in the account after 4 years? So that means now my T is equal to 4. So A equals 2,000 times 1.02 raised to the 2 times 4 power. So now, this is what I want you to do. When you have these multiple exponents, you have more than one exponent, I want you to rewrite the equation and write that exponent, this 2 times 4, as one exponent. So it's 2,000 times 1.02 raised to the 8th power. Now, once you do that, you can just plug this into your calculator. So just plug that into your calculator just like that. But always do this after you multiply this here. Don't try to plug in more than one exponent. Usually kids will mess that up. So just change that, multiply that, make it 8. So plug it in your calculator, and she will have in her account after 4 years $2,343.32. Okay, so that's it, and we will practice some more tomorrow in class. All right, have a good night.